Good afternoon, everyone. Today we're going to talk a little bit about latent growth curve modeling, structural equation modeling, and an analysis of mediation over time. So I am Kara Rutter, and I have my fabulous colleagues with me. Nikki, would you like to introduce yourself?
Hello, colleagues and watchers. I'm Nikki Abbott.
Hello, Dr. Ryan. Hello, guys. I'm Marvin from Public Health Sciences, and let's hope you guys have fun with us.
Well, I am sure they will, because we had a delightful time putting this together. So we have prepared a very long R script, which we'll be running through. And then on the side of your screen is also a PowerPoint, which will kind of talk through the different steps of the process. So if one of you would like to kind of talk about what we're doing here today, our considerations, and some of those other issues before we jump into the code.
Sure, I sure can. So in this video, we're gonna guide you through this step-by-step process. Like we said, it's a long R code. We'll try to keep it condensed, but overall, we're gonna be doing some modeling and also simulating some data. We're gonna go through some confirmatory factor analysis, structural equation modeling, and finally a latent growth curve modeling approach. The data we're going to be going through here, is it on the considerations? Yes, it is youth sparks. How does this have a relationship with social competence? And our hypothesis is that this is mediated through growth mindset. So we have some considerations that this was a planned missing data design. So there's only a few of the variables that we do certain preparation for, and other ones that we don't, just because these were planned survey questions for certain participants. Anyone have anything to add to that?
Um, okay, just for like the data preparation, basically, I think what we'll be doing is basically we're gonna be screening for multi-grade outliers. We're gonna be screening for extreme missingness, and then also going to be ruling out outliers and straight liners, sorry. And then we'll carry out some imputations, and yes, then we'll go to do some confirmatory factor analysis before we finally do our structural equation modeling. So that's just the summary of our analysis here.
Perfect. Well, let's dive in. So we have already set our working directory. We've installed the necessary packages. All the packages are listed here at the top of the code so that when you're running through the code again, you don't end up with any conflicts. Our housekeeping is complete. We have a clean copy of the data set on our desktop, which is our working drive. And we've set a seed for reproducibility. That way, every time that we're running through the code, we end up with the same information. So we're just going to run this first section, and this is what Marvin alluded to as far as our data preparation. And so we'll scroll back up here. So we've imported the data file and wrote a CSV. We've filtered the data because we're looking at only observations 1 through 1,319 in our data set. And then we've subset the data to look at the youth sparks, growth mindset, or social competence and growth mindset. So there's our information, our values there. We've described the data so we can get an idea of just what's in there, what it's looking like, what our current mean standard deviations are. So then we're going to look at the standard deviations of each row so that we can filter out those straight liners that Marvin talked about. So we took straight liners literally, so anyone who has a standard deviation of 0. And so we removed 91 cases for straight lining. And then we started looking at outliers. And so as Nikki mentioned, we only looked at outliers on USparks because that was the only complete section of our data. Social competence and growth mindset only have about 30% of the data. So we subset the data. We calculated the Mahalanobis distance. We created an outlier flag. We counted our outliers. And so of the original 1,319, 1,228 remained after our screening for straight lining. Of these, 109 are outliers. So then we bound the data back to the original subset data and removed those 109 outliers. Once we got the outliers out of there, then we set up imputation. And so we used imputation with norm knob for normal imputation without Bayesian smoothing. We did this because this was an appropriate imputation method given our PMDD. So we have the completed data set. We'll take another look at the completed data set. And you can compare this back to your original data set to make sure that nothing has been skewed too much. If you look through the means, they're all, they're all pretty close to what they were back in the original data set. So now our data is ready to go. And so we've kind of gone through all of those things. Is there anything either of you would like to add on the data preparation process?
I think you're spot on with the data preparation.
All right. Well, that's something that we've done several times. So we kind of breezed through that so we can get to the real meat of our study. And that is confirmatory factor analysis. So we'll run this. And we have a very pretty graph chart picture of our confirmatory factor analysis. So we'll take a little look at the code first. And so we have, this is our CFA model. So we have all of our manifest variables loaded onto their latent variables. So youth sparks, social competence, and then growth mindset. So we have our between factor correlations that we're looking for here. And then we did CFA fit with our completed data and a summary. So would one of you like to chat through what we found in our CFA model?
I can kind of explain just the background of the CFA model. So basically we do this to ensure that our model is measuring what we want it to measure. So there's a few scores that we want to be relatively high, like the CFI, the TLI, I don't think the RIMC on here.
Yep. So
and the RIMC, we want that to be lower. This is our the squared error. And something else that we look for in here is our chi-squared statistic. And our chi-squared here did show that it is it is a significant with our p-value there. So it basically is saying we are doing what we want to be doing. So we have a good model here.
Also, I think initially we'll look at the convergence and the number of iterations when you scroll up.
Yeah.
So yeah, there was good convergence and up to 22 iterations. So that's also something I want to check.
Yeah, absolutely. And so then once we get through our kind of model fit indices, one thing that we really want to look at is are all of our are our factors loading like we think that they're supposed to be loading? And they all are. So the lowest factor loading that we have was the 0.619, which is still within that kind of generally accepted loading framework. So our CFA looks good, but let's look at a structural equation model to kind of make it make sense and look at a little bit more of the indirect effect and the direct effect. So here we've built a structural equation model. And we'll just run through this so we can pop up with our pretty pictures. Okay. So on our structural equation model, it's gives us a lot of the same information as before. So it converged normally after 30 iterations. Chi-squared is very similar to our last chi-squared. Degrees of freedom are the same because we're really still looking at the same number of things. So we'll look here at our CFI and TLI, also about the same as with our confirmatory factor analysis. Our RIMC, exactly the same. Our factor loadings are still all very good. But then the structural equation model tells us a few more things that we didn't know before in a confirmatory factor analysis. So what it really tells us is these regressions. And so that's what we're looking at, and that's what we'll continue to look at for the bulk of the rest of this presentation. And so from F1 to F12, so that's the A path. So that's youth sparks to growth mindset. Our regression is 0.295, so almost 30% is due to growth mindset. Our B path is from growth mindset to social competence. It's 0.324. And then our C path is that direct path between youth sparks and social competence, and that's 0.295. So we'll continue to compare these three over our next three models and see if those relationships stay the same. So we have our intercepts here and our variances, our R squared for all of our manifest variables, and then also the latent factors. And then here's the indirect effect, so 0.096, and the total effect, 0.390. So this plot, open for me. Oh, there we go. This is what SCM will spit out in that SEM plot. And so some of these may be difficult to see, but that's our A path, our B path, and our C path. And these are all of the factor loadings. So as you can see, our factor loadings are all still very good. Okay. So we've put together our initial structure equation model, and it works, which is great. And now if one of you would like to introduce what we did next. Well, stay on this as far as the waves.
Yeah, so can you expand that just a hair? Just the script. But so for this, we were given some criteria for our simulated data, and some of these things involved finding the standard deviation of these factors. So we chose to create composites first of each of our latent variables, and we utilized the standard deviation of those composites to then run all of this simulated data across 3 waves. So you can kind of see here within all of our factors in the waves, they had some different criteria. One was to increase, one was to stay the same, one was to decrease. There's some random error in there, and you can see those values in here, again, multiplied by the standard deviations of these factors.
Absolutely. And so wave 2, so we decreased youth sparks, we increased growth mindset, and social competence stayed approximately the same. And then wave 3 is built off of wave 2, and once again we increased growth mindset and decreased youth sparks. The idea is that as the participants age, youth sparks will diminish and growth mindset will increase. And so what we want to assess is, does that change in youth sparks going down, growth mindset going up, affect the relationship with social competence? So we will run this, and we're using mutate, so we're putting all of this data back into our completed data set. We should probably look at the output here.
That is the idea. You don't have 18 more data sets there. I love that.
Yeah, absolutely. We end up with enough of them at the end that it's nice just to mutate it. So here's our the head of our completed data. And now we want to look at correlation matrix to make sure that we did what we thought we did. So we'll do one for F1, one for F7, and one for F12. And so we can pull them up. As you can see, wave 2 and wave 3 are all highly correlated with the original wave 1. So it appears that we did what we thought we did. So now we're going to run essentially the same process, the same SCM on wave 2 and then wave 3. So we've already discussed that. We'll just talk briefly about the findings. But our wave 2 ended normally after 28 iterations. Our chi-squared, significant, again, very, very similar values. Our CFI, TLI, very similar values, and the same with our RIMC. In fact, it was a little bit lower. And wave 3. Wave 3, 29 iterations. CFIs, or the chi-squared is quite a bit lower here. Still significant. CFI, TLI, both very acceptable, as is our RIMC. So with that, we want to take a look. We'll We'll make this big so we can see it. So this was our wave 2 and wave 3. We did all of those. And so these are our 3 SEM models. So what we found was that they're all relatively stable across all 3 waves. So all of our values are very similar from one to another, but you can see what's happening to our data. So youth sparks, the intercepts there, obviously they're going down in wave 2, down even further. Growth mindset is increasing. And social competence is almost exactly the same across the 3 waves. So we'll get that out of our way, and somehow we ended up back at the top. All right. So now we want to see if our models are related to each other, how our models changed. And so we used lab test LRT first to compare our CFA fit and our SEM fit, which we know just from looking at them, they should be very similar. And we found that, in fact, they are. There's essentially no difference in the chi-square between CFA and SEM1. So now we want to look at the 3 SEM and see how they are together. And so this is where we have a little bit of a difference between our 3 models. So the negative chi-squared value indicates that our wave 2 model fits better than our wave 1 model, and our wave 3 model, once again, also fits better. But all 3 of them fit very well. All the values, the model fit indices, were all well within the range of what we expected. To make it easier, when we were writing the paper, we ran parameter estimates, and this is a very valuable tool when working with SEM. So if you run these parameter estimates, it gives you all of your factors that you're looking at in one place. And so you have your paths, your regressions, standard errors, everything is presented very well. And then we do like our pretty pictures. So we ran this. And this is a mediation effect plot that is basically showing us our A path and our C path. And so here, the height of the triangle made by the 2 is our indirect effect. Okay, so now we want to talk about latent growth curve modeling. So to do so, we created composites of the latent variables F1 and F12, no, of wave 2 and wave 3. We'd already created a composites of earlier for wave 1. And so we'll just run those. And then we set up the means. So we looked at the mean of each one of our composites over the 3 waves. And then we want another pretty picture here. So we're binding the means together against time. And then combining the data frames so that we can do a little ggplot action, because we hadn't done that all semester. So here is our mean and time. With growth mindset increasing, social competence remaining the same, and youth sparks decreasing. And we got to use ggplot, so win-win for everyone. All right. Now we're getting into our latent growth curve modeling. So with latent growth curve modeling, we're looking at the intercepts and the slopes. So we're controlling for the intercepts, and we're adjusting the slope over each wave period. So this is our latent growth curve model. And we got some craziness going on. So in this latent growth curve model, we treated social competence as a manifest variable rather than a latent variable. And the reason that we did that was because social competence doesn't change over the 3 waves. And so we were having problems getting a model to converge with all 3 waves, treating all 3 factors as latent variables, with social competence remaining static over the 3 waves. So instead, we've focused on the change of F1 and the change of F12 in relationship to F7. And so that's what we've done here. So results from this are very similar to SCM. It took more time this time with 372 iterations. We do have a warning that some of our estimated variances are negative. So that's likely a Haywood case due to the complexity of this latent growth curve model. So we do have to be cautious in accepting any data that is not, it is not listed as significant. Variances should not be negative because it's a squared product. And so as you can see here, once again, we controlled the intercepts for both factors, and then we stepped up the slope on each one of them. So this gives us our regressions, our covariances, the intercepts, and our variances, and a pretty picture. And so you see we have the paths for our intercept values. We have our F1 intercept, our F12 intercept, our F1 slope, our F12 slope, and the 3 waves feeding into each of those. And so the positive coefficients suggest that individuals with higher initial levels of F1 and F12 are more likely to have higher levels of F7, which is what we found all along. They have a good relationship between youth. There is a significant relationship between youth sparks and growth mindset, and that's what we hoped to show. And that concludes our R code. Nikki, Marvin, what would you like to add?
I feel we need to see that final model in the presentation just because it's a really good visual.
This?
No, in the, well, yeah, that just gets a little confusing, but how you structured it in the PowerPoint looks a little prettier.
So this is our latent growth curve model. It's a little cleaner here without all of the error terms. And so we have our U-Sparks intercept, our U-Sparks slope, growth mindset intercept, growth mindset slope.
Yeah, I
Well,
just
our
appreciate
patterns.
it. But yeah, all those positive values are good to see. These intercepts, they're kind of like the baseline, and it was good that we were able to simulate this data to kind of see a longitudinal analysis versus just a cross-sectional one. Sometimes there's a lot more power in seeing things change over time. So these slopes, I know like growth mindset had a pretty high slope too. So we do see some decent changes throughout this. Anything to add, Marvin?
Yeah, no, I mean, ultimately, I think, I think what we're struggling with during the initial part of the analysis was being able to demonstrate that longitudinal change over time. I think ultimately we're able to show that, like youth sparks, growth mindset, higher initial levels lead to higher social competence over time. So I'm happy we're able to demonstrate that. So I think we're good.
Yeah, absolutely. I think I think all three of the SCM really demonstrated that with a decrease in youth sparks and an increase in growth mindset, which is the expected natural state, that social competence remains the same. And so social competence is not falling off as youth sparks decreases, because that's mitigated by the mediating variable, which is growth mindset. And I think that all of our models showed that over time. So great success.
So
Great job, team.